Yeah, notice how we're all, I have a very dear friend, Dave Peterson, N7BHC. We met when I was in Utah, stationed in Utah, and notice that he has a PJ4 call sign. He is doing missionary work as a technician engineer for radio networks. So this TWR, if you go to the web and put in TWR dot, and this is ORG. Okay? Oh, I didn't turn it on. Check, check. And so this is TWR. This is the missionary work. This is, they put up radio stations all around the world and broadcast. Dave just was recently on Bon Air in, for the geographically challenged, Bon Air, B-O-N-A-I-R-E. Yep. So this is kind of cool. So here's the island, and watch this. I'm going to step out, and then you'll get a sense. Here's Caraco, Aruba, then there's Venezuela. So imagine being stationed out there for several years, and there's a high-powered transmitter station located there. All right, let's go back to the PowerPoint, F5. Alt or F, function F5. Function F5, come on. Fumble fingers, my goodness. Okay, thank you. All right, next up. So, Transworld Radio is a multinational nonprofit broadcaster. It first broadcast in 1954 from Morocco and has grown to several thousand outlets spanning 260 countries and 230 languages. So Dave has worked with TWR since 2009, most recently in Bon Air and in Southern Caribbean, where they installed a 440 kilowatt medium wave solid state transmitter. So there for you gallon kilowatt transmitters out there. So it is essential to know how effective the broadcasts get out, so they do monitoring and reporting of signals as traditionally done by trained volunteers mailing in reports. These monitors have been supplemented by remote analog receivers for many years, such as what you see here, the Kenwood R2000 and the Tentec 320Ds. They fed data back to a central computer for analysis. Analog receivers are becoming harder to find. Modern SDR receivers offer a lot more capability and features. So TWR is moving towards a network of remotely controlled SDR receivers. They are connected over the internet to a centralized computer that controls them and stores and analyzes monitoring sessions. So there are three phases to this project: the actual receiver system, a localized single board computer, and a centralized global master controller. Users worldwide access the central server to schedule data gathering sessions on a remote receiver. The central server commands the local single board computers with scheduled commands. The remote receivers record their measurements to the attached single board computer. The central server pulls the data from the remote computers, and reports are available from and data archived on a central server. TWR investigated a number of receivers over the last 2 years. The Kiwi SDR meets most of the specifications at a good price point. The ability to receive multiple channels simultaneously is a big plus. Channels not being used by TRW, I'm sorry. I think you got that backwards. Have been available for general public use on some of our sites. We have also standardized on the W6 LVP, we have also standardized on the W6 LVP loop as the recommended antenna. The Kiwi SDR is controlled by a human operator via web browser We need unattended operation capability. So a single board computer can replace the human operator for controlling the Kiwi SDR. It can be set up for scheduling recordings, starting and stopping at various times, and storing parameters such as single strength, modulation index, and sample audio waves. TWR started developing the software to run on a Raspberry Pi. And the global network monitoring system needs a single point of control and data storage. And the third element of our planned system is a centralized service where monitoring staff can control and recover data files rather than contacting the myriad of sites. So I'm going to skip to here. What this basically is a call for help, because they need help for developing this software. So they've gotten this far in their research and putting it together, and we require urgently of someone who can take on the task of finishing up and coding and documenting the software for the single board computer. The software is a mix of database management, receiver control, scheduling, and signal analysis. This aspect of the project needs completion within the next 6 to 8 weeks. Come on, how many of you finished something the night before? All right, so TWR is a not-for-profit organization. The work can be performed on a volunteer or as a paid project. So if you are interested, please contact Dave at dpedersen@twr.org. And that's all I have.